Hi, I'm Harshana. I'm a fourth year IT undergraduate at University of Morador. So today I'm going to explain xerces-wasm architecture. Actually, this is a pretty cool architecture I have made. That's why I'm doing this video. So first of all, I'll explain why I started this project and how I made this solution. So in WSO2 internship, I was working on XML tooling for browser environment. So I wanted to validate XML file against to the some heavy XSD files directly directly in JS without hitting a backend or running a JVM. So I searched about what are the existing packages. So there were few packages, and most of them rely on OS native and or want some kind of backends. So there were some few packages which JS natively can handle this part, but it cannot handle heavy XSDs. In the WSO2 I had some heavy XSD files, so that's why I started this project. So I got this idea from my senior. My senior Tuaya said, what about Apache Wasm, Apache XS? If we can turn it to a Wasm, then we can use it in the Node.js environment. So suddenly light bulb. So then I decide, let's check what is the capability to Apache C++ compile to WebAssembly. Then after a few tries, I could do that thing, but I felt dumb because every single validation runs was resending and recompiling the schemas. Then I decided I should think about what I can do for that. So I went the XSS C++ validation engine architecture. So I'll explain what is the architecture, the stages of that. Then I'll say what is the solution I gave. So in the XS engine, there are two main stages. First one is the XSD compilation part, and second one is the validation part. In the XSD compilation, so what we are doing is when we are sending the XSD files to the Apache XS, it converts into the grammar pools. We call it as grammar pools. So it is an internal process. This is the heavy phase. So engine struggle with most of times this part. So validation part is easy. Validation part is easy because it make a sax parser, temporary sax parser, disposable one, and pass in the grammar pool and the XML files. Then that sax parser can validate this XML file against to the XSD files. That's how it happened. XS engine's validation part. So I think the other npm packages and most of times it does XSD compilation again and again. Then that means if I want a validation, then I'll send a validation from the client to the server. Then it sends XSD files and XML file both. Then XSD files all times it make a grammar pools. So we don't want to do that because if we can cache this grammar pool, we don't want to do this again and again because we already have grammar pool. So that is the what I tried to do that. So and I had another challenge. This is the first challenges I had. When we are compiling the XS engine to Wasm, we can't find directly from the disk. In the Wasm, it is a sandbox environment. We can't read disk from Wasm. So XS engine is built for reading files in the disk. So when I converted it to the Wasm, so Wasm cannot give to access to disk. That's the one case, first challenge I had. So what I did is I'll pass the raw text into Wasm. In the Wasm I made some memory map, memory entry. Then I'll make I make a memory link inside the RAM and then give that link. So that's how I solved that problem. So after the second problem is, as we talked, the compilation part. So how we cache this grammar pool. So that is the second challenge was. So this is the architecture. I will show you how it happens. Then when we are sending the XSD files into a XS, so it makes a grammar pool. This is the internal process how it makes grammar pools. So then we are sending the XML file what we want to validate against to this grammar pool. Then it passes grammar pool, then search engine validate gives valid result. So the architecture is I think what we can do. I thought about what we can do. Then I learned about the WASM linear memory. In the WASM linear memory, we can keep some stuff. It's like a RAM, but inside the WASM, how it's I mean the RAM means it's not a physical thing or like that, but it is a dedicated memory for the WASM. So inside the WASM package, so it is included in the sandbox. Then if we can keep the grammar pools inside that WASM linear memory, then we can use it. So after a few approaches, I can do that. Then what I did is when compiled first time, then keep it in the WASM linear memory as a cache. So if there is a two project, I think there are two projects with the two XSD schemas. And first of all, I'll explain. There is a project-based approach. That means if we can keep multiple projects, and if they are rely on the not the same schemas, then we can keep like this. If all projects keep like the same schema, like think there is a one schema for multiple projects, then it is okay. We can keep one grammar pool because we already compiled it. We can use it again and again. So for example, let's see there are two projects which has different schemas, and project 1 has a project 1 XSD schema list, and project 2 has a project 2 schema list. So then what we are doing is the first validation request, it should pass the XSDs. Then we are compiling it to the grammar pool and cache them in the WASM linear memory. Then again time if it asks about the give me validation for this file, then we know what is grammar pool. How we know it is which grammar pool is project 1 grammar pool? Because when we are creating a grammar pool, it send the memory pointer to TypeScript side. Then that means in the actual object is creating in the C++ side, but we will send the pointer to TypeScript side. Then we have the TypeScript side, we have the pointer, so we will send with the pointer. Then let's think there are multiple files, it's sent to the WASM, then it will make the disposable sex parser. Actually, I also think why we make rebuild the sex parser again and again, because it is a very very lightweight thing. Therefore, we don't want to consider about that. This is the architectural decision of the XS also, but there is no any advantage if we can keep this permanently. Then as a old request, it make the disposable sex parser, then validate and it will destroy. So that is the architecture of the XS. However, so if there is multiple files, so I'll send the file 1, then with the pointer, in the pointer WASM know which grammar pool I should use, then it will use and give the result. Then if it comes the another files, we will validate like that. We don't rebuild. That is the actually pretty smart thing here, because I studies about all of most of existing packages. They always should send the XSD files into their engine, because every time it doing the parsing part and the making grammar pool part. So we don't do that. So that is the smartest thing, as I always explain. So now you can the project 1 2 handler, there is another rule set. So we will cache it if it comes from the this project. We know what should use, and this is the actually architecture of our. So I'll show the quick example. So we have the quick create a project validator. When we are installing the xerces-wasm, we can import it. So we can make I said one XSD schemas. That means schema set equal to the project in this project. So we can make a schema set. So I'll make a v means one schema set. There is a main entry point we should mark. In the XSDs we should mark the entry point. So there is a main entry point. Then we can pass the files and we can make a project validator. We are calling it as a project validator. So using project validator, we can send the validate function. We can call the validate function with the raw XML text. So it will give the result. So and we should destroy after we are using the project validator, because in the C++ side, even we are compiled into WASM, it is a C++ code. So there is no any garbage collectors. So we should destroy it after using it. That's why we are using destroy function. So okay, that's the how the architecture and how the how we use it. So I'll show you some browser playground. I made a browser playground. So there's a GitHub repo also. So let's go to the browser playground. So in here we are doing everything in the front end. We don't call to the back end because we in our npm package we can run it inside the front end. So actually it's very nice because we can add the multiple files also. So even yeah, we can add the multiple files, and we should mark the what is the entry file. So after that in accessory, you know that we should mark the entry file. So after that we can validate this. For example, let's check with some grammar error. So like that it will show the errors. Okay, so just try this, and we did some benchmark also, but in this video I don't going to tell about it. In the benchmark speed we got the very faster benchmarks, and sometimes we had some lower because we are all handling in the main thread. That's the case because JavaScript is a single thread programming language. We didn't pass it to the worker thread, so that's why it has some slow. There's no any huge difference, but there is some small difference because of we don't handle it in the worker thread. So I opened GitHub issue also, so but we will implement the worker threads also, so then we can get more speed than this. But in the schema files are very slow, very low, size is very low, then it's a super fast. So you can see what is the speed, some 500x speed we can take. So it is actually it's not a 1 or 2, then it's a 700 speed, so it's a huge. So okay, I explained why we are slow sometimes, and also so I already explained why we are slow, because we are using this is in the main thread. That is the reason why it happened. Okay, so about benchmarking, I'll do another video about benchmarking also. So okay, thank you.